Hello, everybody. Good to have you here. Welcome back to another video. Today, we're going to be integrating sine squared x, cos squared x, and other further trig kind of questions. But I guess we'll start with a joke. What did the buffalo say when his son went to college? Bye, son. Bison, buffalo. Okay, let me share my screen and let's get to it. So today, we will be looking at integrating sine squared x, cos squared x. Now, the first thing that I need to put out there very, very clearly is you cannot straight integrate sine squared x or cos squared x. Not possible, doesn't exist, not in this course. Right, so what we'll need to do is we need to use the following identity, and this is the one that's given to you in your reference sheet. Okay, they'll say sine squared nx, so if there's a coefficient of x, that's what n is, and they've written it as half bracket 1 minus cos 2nx, or if it's cos squared nx, it can be written as half out the front of 1 plus cos 2nx. Now, the way that you'll see it, I'll show you, looks a little bit more like this. They'll say evaluate, oops, let's see if I can get my pen. And let's use blue. They'll say evaluate sine squared 2x between 0 and pi. And so I know that this is going to be the same thing as the integration between 0 and pi. I'm going to rewrite it as half bracket 1, and because it's sine squared, it's going to be 1 minus cos 2 times n, which in this case is 4. So it's going to be cos 4x. And that's what we're going to be integrating, dx. Okay, now what's nice about this is I'm just going to rewrite it as, I want to take the half outside, but sometimes you can leave it in. So it's going to be half at the front of, and I'm going to integrate. 1 becomes x, and then minus cos. So remember, sine, cos, minus, minus. Negative cosine will actually integrate to negative sine. So it's going to be minus, minus cos will be turned into minus sine. So it'll be minus a quarter sine 4x. That's just your integration of cos 4x. And then it's going to be between 0 and pi. And from here, we just evaluate. It's going to be half out the front of, and it's going to be pi minus quarter sine 4 pi. And then take away 0, take away a quarter sine 0. Okay. So that just ends up becoming 0. And so my answer should become half. And then sine 4 pi is actually just 0, because I know sine 2 pi is 0, so sine 4 pi will also be 0. You can put that in the calculator to double check if you don't trust me, but that will just become half pi, or pi on 2 units squared, because we're talking about area under a curve. And that's that. Okay, now they might have other things where you'll have to recognize and use the reverse chain rule. So it happens in a couple of different forms. The first one is if you see cot or tan. Cot's a very interesting one because cot can be the same thing as cos x over sine x dx. And you will notice that it kind of looks very, very similar. And I'll write a little note here. It looks very, very much like f dash x over an original, which is, if y equals to ln of a function, your y dash equals this. Okay, so I know it's going to come up as an ln. Now I know if I differentiate sine, it should give me cosine. So it should just be negative ln of my function, which in this case is going to be sine x and then plus c, because that's going to be your constant when we integrate, and there's no definite integral here. Okay, now this one here is another version of the reverse chain rule. Now here, what I'm looking at is that's the thing that I'm looking at. Okay, the thing that's raised to a power. Now I notice that if I say fx equals to cos x, what does my f dash x become now? It becomes negative sine x, and it looks very, very similar to what we have out front. So all I need to do here is take a negative out, and so now I've got negative sine x cos cubed x dx. And that there is in the form that we want because we've got the derivative out the front. We've got the original that's raised to a power, and I know that's just going to be the function. So in this case, it's going to be cos, in this case, to the power of 3 or to the power of 4, because we're adding 1 to the power, cos 4 to the x, and I'm going to divide it by the new power plus c, and I have this negative that's kind of been carried on from there. And so that would become my negative cos to the power, or cos x to the power of 4 over 4 plus c. That would be our, what's the word? Primitive, okay? So hopefully that makes a bit of sense. I know that was a little bit short, but hopefully those examples help you out with those questions. All right, thank you, and I'll see you guys later. Bye-bye.